This is 3.A.2 homework. Problems numbers 3.72, 3.74, 3.92, 3.98, and 4.102 and 4.104 from the Chang book. The first one is a stoichiometry problem, 3.72. The glucose breaks down into 2 moles of ethanol. So we start with 500.4 grams of the glucose. We change it to moles by dividing by the molar mass of glucose, 180.18. We then change to moles of ethanol by multiplying by the mole ratio of 2 to 1. And then we change to grams by multiplying by 46.08 grams over 1 mole. This gives us the first answer for 3.72, 255.9 grams of ethanol. Then the second part is to change the grams to liters. They tell us in the problem that the density of ethanol is 0.789 grams per milliliter. So dividing the mass by the density, I get 324 milliliters. Dividing by 1,000, we get 0.324 liters. So two answers for 3.72 are 255.9 grams and 0.324 liters. 3.74 talks about the reaction between gold and potassium cyanide, oxygen and water, to make the potassium and gold cyanide product and potassium hydroxide. So the moles of KCN needed to get 29 grams of gold, or an ounce of gold. First we divide 29 grams by 196.97 grams per mole, and then multiply by the ratio of 8 over 4, and that gets us our moles of KCN. No need to change it to grams. 3.92, hexane makes ethylene. According to the problem, it's a 1-to-1 ratio. It does make some other products, but we're not concerned about that. We're looking to produce 481 grams of the ethylene, but we realize that the process only gives 42.5% yield. So 42.5% is 0.425, and that decimal should be 481 grams, the actual hexane, or actual ethylene actually, over x grams theoretical. Rearranging that algebraically, I get x equals 481 over 0.425. So in other words, I shoot to make 1130 grams of C2H4, realizing I'm going to fall short and only make 481 grams, or 42.5% of 1130, because the process is not 100% yield. So if I theoretically am trying to make 1130 grams of ethylene, then 1130 divided by 28.06 will give me my grams of moles of ethylene. 1-to-1 mole ratio gives me my moles of hexane, times 86.20 gives me my grams of hexane. Change it to scientific notation so it fits the answer in the back of the book. 3.47 times 10 to the third grams of C6H14. 3.98. This is a problem that we've seen before where we have to find the empirical formula. So the first step in finding the empirical formula of a chlorine-oxygen compound is to find the moles of chlorine and find the moles of oxygen. Well, we've reacted the compound with hydrogen and turned the chlorine into HCl and the oxygen into water. So if I take 0.233 grams of HCl and change it to moles, and then realize that for every mole of HCl, I have a mole of chlorine in its formula, then I find I have 0.00639 moles of chlorine. doing something similar with the water, 0.403 grams of water divided by the molar mass of water gives me my moles of water, and then I recognize that for every mole of water there's 1 mole of oxygen. So it's 0.0224 moles of oxygen. Now I'm at the point in my process where it's time to divide by the smallest being 0.00639, which gives me 1 chlorine for every 3.5 oxygens. Now multiply till whole. 3.5 needs to be multiplied by 2 to get 7. 1 times 2 will give me 2. So my chlorine compound is dichlorine heptoxide. 4.102 looks at the reaction between magnesium and hydrochloric acid to make magnesium chloride and hydrogen. 4.47 grams of magnesium get this adjusted here. .47 grams of magnesium will be divided by 24.31 to get moles, and then times 2 to get the moles of HCl. And so there are 0.36 moles of HCl used. You started with half a liter of 200 or 2.00 molar. Liters times molarity equals moles, so you actually start with 1 mole of, sorry, this says Mg, it should say HCl. 1 mole HCl initial minus 0.368 moles used leaves me with 0.632 moles of HCl left. Now it said that the volume did not change, and so 0.632 moles of HCl left in solution and still in a half-liter solution means the molarity of the HCl has gone down from 2 molar to 1.26 molar. The magnesium has reacted with it, so the molarity of the HCl has gone down. And finally, 4.104, we are standardizing sodium carbonate using, or standardizing HCl using sodium carbonate. So we just need the reaction Na2CO3 plus 2HCl yields 2NaCl plus H2O plus CO2. Change the grams of sodium carbonate to moles by dividing by 105.99, the molar mass of sodium carbonate, and then multiplying by 2, we get that 0.00483 moles of HCl reacted, and that divided by 28.3 milliliters changed to liters gives 0.0238 liters. Moles divided by liters gives a molarity of 1.71 molar.